So my name is Andrey Kudryavtsev. I'm DAOS product manager at HP. Also have a long history working at Intel, and since February of this year, part of HP team. What we're going to talk today is the idea of the HP portfolio of the server products and the reference design for the DAOS architecture. And I want to bring some discussions here about this portfolio overall. I found it, well, very impressive by the number of configuration options that they provide, and also by just a variety of different systems that you can pick from. And we will look at the reference design that we are proposing here. So I only have a few minutes, so I cannot go really deep inside it, but I will start with painting a bigger picture. We really working on the on a variety of different platforms that can be used for DAOS installations. And some of these platforms are more optimal, some of these platforms are less optimal. Depends on the needs of the installation, the number of NVMe SSDs, the fabric configuration, the CPU choices, and the number of these CPUs. So within our group, we were looking at the several configurations, and well, there are two interesting choices that we are looking here in the middle section. So obviously there are some compute optimized platforms or some GPU optimized platforms. That's not what we're focusing, at least in this particular presentation. And what I'm showing here is the density optimized platforms that specifically designed in some of these configurations for storage use cases. So the platform that I'm going to talk just a few minutes about, DL360 Gen 12 platform. So that's the latest platform delivered from the HP. It was introduced last year, the first, the Intel Sapphire Rapids, I'm sorry, Sierra Forest, what I'm talking about, Sierra Forest CPUs, and now it came later with a Granite Rapids CPU. So it's a dual socket design that is, by the design, it's a 1U rack system that has enormous options for different types of the configurations. And it's like one of the modular, one of these type of the workhorse solutions from HP, where you can really configure it to the needs of the environment. And for different types of installations, for compute-specific installations, for storage, I will show the options, for different examples of a cooling, with air cooling, the direct liquid cooling, with closed-loop cooling, and so on and so forth. And obviously, the use case for this platform is really vary from the type of like infrastructure use cases to the computing use case. So when we started looking at the definition of this platform, it has a modular design that allows to configure the front bay for the storage options that really needs in the solution, and needs to be really coupled and optimized what you have on the back. And I will show the back side on my second slide. And on the front, you really configure it with the number of NVMe SSDs and the type of NVMe SSDs. So for us, the most interesting configurations that introduces the high density configurations. And in order to achieve those today, you have to migrate to the latest NVMe technology with the latest NVMe form factors. And HP is driving this with a form factor called E3.S. So that came as a replacement of a U.2, U.3 form factor that is, by the design, started with the PCI Express Gen 4, now PCI Express Gen 5, and it has a full path to go PCI Express Gen 6 just by the overall design of the connector edge, its edge connector on the NVMe SSD. But also, it's much thinner profile, easier to cool compared to the U.2, U.3, and allows to build a higher density configurations. So within this platform, with 1U, we can retrofit the 20 E3.S NVMe SSDs, and they are fully balanced across the dual CPU design. On the backside, we also have a very variety of options for the add-in card expansions, and including the OCP form factor expansions as well. And that is also the preference of the configuration choice. In some of these configurations, you simply go with add-in cards because it allows you to go to the higher thermal profile, and that is the case for the high-performance fabric, as you might know already. In other form factors, where simply might not be available in the OCP due to, again, the challenges of the thinner profile of the OCP card and the amount of the cooling that could be done to this. And simply some vendors are not doing the cards with the OCP. So the platforms allow us to come into the really balanced configuration that you can pick and choose what you want to do. And in our case, we are actually proposing in the reference configuration to use add-in card slot and OCP slots at the same time, so that will drive some extra functionality that the platform can deliver. Internally, I mentioned that already. It's a dual CPU design. It started with Sierra Forest, and it's currently the Grand Rapids SP. So that is socket-to-socket compatible. Grand Rapids SP delivers the P cores, while the Sierra Forest is energy-efficient cores. And we're really looking at this scenario into the P-core configuration to make sure that we have enough or a lot of platform performance to deliver on the tasks that are not only DAOS related, but can accelerate some other possible background activities that run on the same platform. So it's a dual CPU design. It's also, of course, all memory channels routed on these and with the dual DIMM per channel design. And that allows to basically populate a large memory configurations or within the same memory capacity to use less density DRAM memory modules that drives the cost down of the overall memory subsystem. So that's a great advantage of this platform. I mentioned that it's available in several design choices for the cooling, and what is shown here is the air cooling. So you have fans here, but the platform itself is also available with the options for the closed loop liquid cooling. So this is where you have liquid cooling attachment on the both CPUs, and you have a front row of the thermal exchanger, basically the radiator that sits in front, and there's another option where you have the direct cooling, so you still have fans in front to drive the air from the parts that are not under the direct liquid cooling, and the two CPUs are on the direct liquid cooling with pipes going outside. In the proposal for our reference architecture, we are looking on the air cooling design, simply thinks that it fits the power budget that we looked at the DAOS storage node configuration, and it's also much easier to integrate and service in that way. So the platform choices up to 20 NVMe, only looking at the Ether.s configuration of these. They've quite a lot of the cores for the for the overall installation. So it's a 48 core CPU that drives to the 96 cores total. And that is bringing us to what I mentioned already, some additional performance that we can do due to having that many cores. Several memory choices. Again, the metadata on SSD, we are relying on the ratio of the storage to the DRAM capacity today, and with the upgrade, as you heard earlier, there's some again. That's the flexibility that platforms give us. And of course, with the different fabrics of choices, so we have the support for NDR. It's a dual NIC NDR. We have the support for the 100 gigabit Ethernet just in general. So that could be a part of a Connectix 7 or some other Ethernet NIC adapter. And of course, HP Slingshot with the both 200 and the 400 configurations. So that's on the fabric support, still looking at also the management network as needed for the platform deployment and telemetry services and others. And this is where I mentioned that we have a capability to leverage the OCP slots that platform has conveniently for us available. So really looking at that as the reference architecture for HP DAOS type of a configuration, and we think it's a great choice today. It's very dense choice that allows us to build up to the 300 terabyte in one unit node if somebody is targeting very high density configurations, but also it's driving the performance up, and the different types of the NVMe scenario, we can optimize it for the performance needs of customers. So that was my last slide. If you have any questions, feel free to ask or feel free to reach me later.
Thank you, Andrey.
Yeah,
Questions
just
for Andrey?
one thing to add. This is Lance. You've seen me stand up and sort of do this similar presentation before, maybe not as focused on the hardware, but what Andrey presented in the last slide is a continuation of what I've previously presented. So that's, just kind of roll your own DAOS configuration, HPCM deployed with our companion scripts, which are free open source, kind of lean approach to doing this. Mixed with, we've just upgraded the scripts to handle 400 gigabit networks, the NDR and the and the 400 gigabit slingshot. So the Gen 12 servers. So it's just kind of a continuation of that, and until we get full productization plans and execution in place. So feel free to reach out to me at any point for more details on the reference implementation if you like.
Thank you, Lars.